In this session, we're going to see how to use the distance formula. And since it's based on the Pythagorean theorem, we're going to start with it. Now, the Pythagorean theorem, as you hopefully recall, applies to right triangles. If we have a triangle with legs A and B and a hypotenuse C, then the Pythagorean theorem tells us that a squared plus b squared is equal to c squared. Now, taking this idea to the coordinate plane, if we want to know the distance between 2 points, say P and Q, then we can form a right triangle whose legs are the vertical and the horizontal distances between the points. So let's label the points. P is going to be, let's say, x1, y1, and Q is going to be x2, y2. And if we keep the color coding that we have in the original right triangle that we drew, then the horizontal distance is going to be blue, the vertical distance is going to be green, and the hypotenuse, or the diagonal distance, is going to be red. Now, since that's the distance that we're after, I'm going to call it D instead of C. Let's go ahead and label A and B, and according to the Pythagorean theorem, we can say that a squared plus b squared is equal to, in this case, d squared. So now let's consider A. A is the distance between the x-coordinates, and being a distance, we can think of that as a difference. A is x2 minus x1, kind of like we have in the slope formula. Likewise, B is the difference in the y-coordinates, so B is y2 minus y1. Substituting these in the Pythagorean theorem formula that we have, we get, in place of A, x2 minus x1. In place of B, we get y2 minus y1. Now, each of these is squared. There's a plus in between them. And I'm going to go ahead and write down the d squared equals on the left-hand side. So now I have d squared is equal to, what had been a squared is now x2 minus x1, the quantity squared. What had been b squared is y2 minus y1, the quantity squared. But I don't want the square of the distance. I want the distance itself. The way I'm going to find that is to take square roots of both sides. Now, the square root will cancel out the squared. And I don't need a plus or minus in this case because we're talking about a physical distance, which isn't going to be negative. Now, a potential pitfall here is thinking that the radical on the right-hand side cancels out the squares, but that doesn't happen. When you have two terms inside of a square root, things act a little different. In other words, there's kind of an order of operations thing behind the scenes that says you can't take individual square roots of terms like that. In any case, we lose the squared on the left-hand side, and on the right-hand side, we have the square root of x2 minus x1, the quantity squared, plus y2 minus y1, the quantity squared. And that's our distance formula. Okay, so let's write that down. And this is something to be memorized. And if we take a peek inside that radical, the x2 minus x1, since it's being squared, it doesn't matter if it was going to be positive or negative. It's going to turn out to be positive. So in this case, it actually doesn't matter in which order we subtract x1 minus x2, x2 minus x1. Since we're squaring them, it makes no difference. And notice that we're going to add a positive thing, because it's squared, and another positive thing, because it's squared. And if I'm adding them together, this will never turn out to be negative, so taking the square root will always be okay. Let's look at our first example. Here we're asked to find the distance between 2 points P and Q. P is negative 2, 1, and Q is 4, 9. So it's a good idea to write down the formula whenever you need it. It reinforces memorization. So D is equal to x2 minus x1, the quantity squared, plus y2 minus y1, the quantity squared. We'll label negative 2 as x1 and 4 is x2, and then 1 is y1 and 9 is y2. So, fleshing out the formula here, we have d is equal to the square root of x2 minus x1 is going to be 4 minus negative 2. Again, we need to mind our negatives. The minus comes from the formula, and then there's a negative 2, which is the negative coordinate. Anyway, plus y2 minus y1 is going to be 9 minus 1, and that quantity is squared. So, following the order of operations, we're going to do what's inside the parentheses first, and let me make that radical a little more obvious here. And here we have 4 minus negative 2, that double negative becomes plus. So this becomes 6 squared. 9 minus 1 is 8, so we have 8 squared. Let me clean that up just a touch. And so we have that the distance is equal to the square root of 36 plus 64. And this doesn't become 6, the 36, and the 64 doesn't become 8. Okay, we need to follow the order of operations, which says that we need to do what's connected all together inside of something first. So 36 and 64 turn out to be 100, and so this distance here is 10. Next we have find, what is this? This is just notation. D parenthesis P comma Q, it's just saying find the distance between P and Q. And we're given P is negative 3, negative 2, and Q is 1, 4. Why don't you pause the video and work this one out? Okay, I'm going to label negative 3, negative 2, x1, y1, and Q, 1, 4 is going to be x2, y2. It really makes no difference which one I put first. So the distance formula is d is equal to x2 minus x1, the quantity squared, plus y2 minus y1, the quantity squared. Fleshing this out with our labeled coordinates, we have 1 minus negative 3. Again, we have that double negative. Be careful with those every time you see them. And 4 minus negative 2. Each of those is going to be squared. Let me tidy that up. And so d is equal to, simplifying inside the parentheses first, we have double negatives in each case. And so we have the square root of 4 squared plus 6 squared. Let me tidy that. And that becomes d is equal to the square root of 16 plus 36, which is 52. So d is equal to the square root of 52. Now 52 can be factored into a perfect square times something. So 4 times 13, and the square root of 4 is 2. So d is equal to 2 times the square root of 13, emphasizing we need to simplify radicals, and sometimes answers don't look pretty. Finally, we're asked to find all points having a y-coordinate of negative 2, whose distance from the point negative 1, 3 is 13. This is a different situation. We're given the distance, it's 13. We're told a point, negative 1, 3, and having a visual would be good in this case. So here we have a coordinate plane, and the point, negative 1, 3. We want to find all points having a y-coordinate of negative 2. Negative 2 is down here, and so all the points having a y-coordinate of negative 2 are going to be on that line. So here's the thing. Find all points having this distance of 13. To the right, we're going to have a point. To the left of negative 1, 3, we're going to have a point. And the idea is the distance in each case is going to be 13. So what do we know about these points that we're after? I know that they each have an x-coordinate that I don't know, and they each have a y-coordinate that I do know. So each of these is going to have the form x comma negative 2. Let's look at the distance formula in this light. So the distance is equal to x2 minus x1 the quantity squared plus y2 minus y1 the quantity squared. So let's label the point that we're after x negative 2. Let's make that x2 and y2. And the point that we have, negative 1, 3, let's make that x1, y1, and flesh out the distance formula with those substitutions. So I have d is equal to x2 minus x1, the quantity squared, so x minus negative 1, and y2 minus y1, the quantity squared, so negative 2 minus 3. But wait a minute, we know what d is. D is supposed to be 13. So we have 13 is equal to the square root of that double negative, x minus negative 1 becomes x plus 1, and that quantity is squared. And then negative 2 minus 3, that's going to be negative 5 squared. So I have that 13 is equal to the square root of x plus 1, the quantity squared, plus 25. I'll square both sides to get rid of the radical. So let me write that like this. 13 squared, and then the radical squared. 13 squared is 169. The radical squared just gets rid of the radical. So I have x plus 1, the quantity squared, plus 25. Subtracting 25 from both sides gives me 144 is equal to x plus 1, the quantity squared. Now, here's the square root property rearing its ugly head. Square rooting both sides gives me plus or minus 12 is equal to x plus 1. And I'll write this as two separate equations. X plus 1 is equal to 12. X plus 1 is equal to negative 12. And now subtracting 1 from both sides will give me x is equal to 11, or x is equal to negative 13. Looking up at the drawing that we had, that means here we've got an x coordinate of negative 13. That one's on the negative side. And for the other one, we have an x coordinate of 11. Remember that in each case, the y coordinate was supposed to be negative 2. That was from the original statement of the problem. So each of these has a y coordinate of negative 2, and I know this is getting to be kind of a mess. So let me bring it down here. We have 2 points. One of them has an x coordinate of 11, and another has an x coordinate of negative 13. In both cases, the y coordinate is negative 2, and the distance between each of these points and the original point that we were given, negative 1, 3, is going to be 13. You could check that by using the distance formula with these points in turn and negative 1, 3, and I leave that exercise to you.